Hey, what's up everyone, and welcome back to another Recall by Dataiku video. My name's Keith Galley, and in this video we're going to be exploring a dataset of Netflix TV show and movie listings. We will begin by answering simple high-level questions such as what is the most popular release year for movies on Netflix? And then we'll progress on to more rigorous type questions. Throughout the video I'll pause and let you try to do the problem on your own before I walk through how I would solve it. There's no one way to approach a data science problem. Depending on the task at hand and the skill sets of your team, different approaches make sense for different problems. In this video, we're going to walk through the same set of questions using both Python as well as the Dataiku DSS platform. So we'll start with Python, and then in the latter half of the video, we'll walk through the same exact questions, but we'll see how we can do it in a different way using Dataiku. And really, the goal of all of this is that to be a great data scientist, a great data engineer, a great data science manager, you need to know which tools make sense when. And so getting exposure to different types of tools will allow you to make those decisions in a more educated manner. Should be a lot of fun. Looking forward to it. All right, to get started, you'll want to go to kaggle.com, and then we're going to download the Netflix dataset from there. I'll also put a direct link in the description of this video so you can go directly to this page that you're looking at right now there. But the data set that we're looking at has all of the listings as of mid-2021 on the Netflix platform. And we can go ahead and download this data set by clicking the download button here. And then you'll want to, once this is downloaded, you want to go ahead and extract it to wherever you're going to work on this. So I'll just put it in a folder called code, and then we'll call this Netflix. Extract it all there. Okay, cool. So we have our Netflix titles dataset here, and we can open that up real quick and just look at it briefly. I think with most data analysis tasks, it's good to get a kind of qualitative feel of the data and just kind of, do a little bit of manual inspection. So we see we have a bunch of information: type, title, director, cast. So a lot of interesting things here. Date added, release year, description, duration. So we'll be answering some questions on all of this information for this entire data set. And so next step, let's open up a Jupyter notebook. And you'll want to open this notebook up in the same location that you saved the data set. So that for me was in my code directory, and then in the recall by data, or in the Netflix subfolder. I'm going to go ahead and open up a Jupyter notebook there. Create a new Jupyter notebook. And the first thing we'll want to do is just import some libraries. So most important one we'll use is pandas. So import pandas as PD. And then once we have that, we can go ahead and start answering the questions. So I'll kind of write up the questions as we go. And really the way I think you're going to get the most out of this video is if you pause the video when I get to a question, try it on your own, and then resume it when you want to see my solution. So the first question is going to be, what is the most popular release year for movies on Netflix? And so when I say release year, I mean literally which year were the movies themselves physically released, not which year were they added to Netflix. So feel free to pause the video, try this on your own, and then I'll show you how I would solve it. All right, so I think a good starting point for any sort of pandas problem is going to be first just getting a sense of your data. So let's read the file. What was the file called again? Netflix underscore titles CSV. So we can access it by doing Netflix titles.csv. And let's just look at the head of that. Okay. Show ID, type, title, director, cast, country, date added, release year. So for this first question, we really need to focus on release year. And one thing also we should note is that we are looking for a release year specifically for movies, not for TV shows. Kind of a first subproblem of this is filtered by just movies. So I'm going to call this movie data frame equals df, and then we need to filter the df by type equaling a movie. Run that, and then we can go ahead and do movie df.head. And we see now we only have type movie. One sanity check that I would recommend when we're doing this is just confirm that the unique values for type is just movie and just TV show. Don't make sure there's no like weird messy data in here. So we can do that by doing dftype.unique. And we see that we do only have two values, which is good to know. So that's just kind of a quick sanity check. Wasn't necessary in this case, but sometimes you'll have something weird, something funky. Someone misspelled movie somewhere. Okay, so we have all the movies. And now we just need to basically group by the release year and do some summing. So that can be done pretty easily by doing a group by. We can pass in the column that we want to group by, which is the release year. And then we're going to want to sum up the values and see what that produces us. And we see here, we get a bunch of like kind of weirdness. When I do this in Python, I usually add I augment the data frame with just a count variable. I think there might be a more succinct way to do this. But what I'll do is just do movie df count equals 1. And so when I follow it up with that group by line, so that means there's a 1 in every one of the rows. So when I follow that up with the group by line, I can access specifically the count column to actually see the meaningful information that I want. So we see all of this nice useful stuff because we just took the count variable. So now what we need to do is actually find the max of that. And so just to make this a little neater, one thing that we can do is we can reset the index and then grab both the count and the release year here. This will actually keep it as a data frame, which will be nice for us. All right, that looks a lot easier, and that's now a data frame object that we can work with. So I'm going to call this release years summed or something like that, equals all of this information. And now what we want to do is take the release years summed, sort the values by count, and we want to ascending equals false. Cool. So we see actually that we have two top release years. We have 2018 with 767, as well as 2017 with 767. So either 2017 or 2018 would be the correct answer here for the most popular release year of Netflix movies in this data set. All right, next we're going to do kind of a similar problem, but instead of figuring out the release year, which release year was the most popular, we're going to be looking at specifically when Netflix added the most content, what year Netflix added the most content to its platform. And for the sake of this question, we're not caring about movies or TV shows specifically. We're talking about an aggregate. So any TV show, any movie that was added to the platform, we're counting for this. And so let's look back at our data frame, and I will add some extra rows down below just to make it a little bit easier and keep this a little higher on the screen. But the one tricky thing here is that instead of just having a year, now we have to specifically, grab the year from a date that was added. And we have to be careful when we do this because you're going to see different types of date formats. So we want to make the most of built-in methods offered to us by the Pandas library. To get this year specifically, whenever we're working with dates, I really recommend converting the column to the datetime column. So if we do df info right now, we're going to see that date added is an object type, but what we want it as is specifically a datetime type object. So to do that, we are going to go and do df, and we can call this, I'm going to call this new date just because I don't want to accidentally erase the old column. Is going to be equal to pd.toDateTime. And I use these functions a lot, so that's why I'm kind of remembering them from the top of my head. But if you ever, the most important thing is that you have a general idea of how to approach these problems. All the time I Google and find the documentation so I can get specifics when I'm doing problems like this. We're going to take the date added column. So df date added. And let's see what happens if we just do that by itself. This toDateTime function is pretty good at interpreting the format of these dates. So it should be able to, without any additional effort, be able to process September 25th, 2021 and realize, and get all the needed information from that. So let's do df new date .head now and see what that's left with. Look at that. We have dates in a nice formatted manner. And so it's super useful. And now if we look at df info, we see we specifically have a datetime 64 type here with new date. And so what that allows us access to is we can add a new column called date added year, which is equal to df new date. This gives us access to this specific extension .dt, which allows us to access different properties from that date. So I could do .dt.year and get that date added year very easily. So now if we do df.head, we see, where is it? It's going to be all the way over here. We see September 25th, 2021 was when it was added. And we see date added year is 2021. That looks good. So now we can kind of do that same exact thing that we did before. And if you wanted to, you could get rid of the new date if you only needed a date added year. It might be worthwhile keeping it because you've converted it to a format. So if you needed to access the month or something, you could still do that. But what we want to do now, and we can do this, I'll just do df.head to make this a little more succinct. Oh, I guess I should take 2 rows. But what we can do here now is exactly a repeat of what we did down below. So I'm going to just copy all of this. Copy all of this. So now we just are working with df. We can add count to the df frame. And we can call this date added years summed, which is going to be df group by, instead of release year, it's going to be date added year, date added year, take the count. That looks good. And then the last step of this was sorting the values So let's run that. Last step here was date added years. And we see that in 2019, 2016 different content, both TV shows and movies, were added to the Netflix platform, which honestly kind of makes sense because I think like the drop off what probably explains it. So we see like 2018, 1649, 2016 is, or sorry, it's weird that this is 2016 because I think it's a date, but we see 2018 you had 1649, 2019 you had 2016. I bet you that this drop off here, yeah, in 2020 and 2021 were probably potentially due to the pandemic and just not as much content being able to be released during that time, I guess added during that time and filmed and all of that. So maybe that'd be one explanation. You'd have to dig into it a bit more, but the answer here to number 2 is 2019. All right, for task number 3, we will answer the question, independent of year, what is the most popular month to add new content? So there's a little bit of confusion between date added and release year. So when is Netflix, what month is it most popular for Netflix to add new content to its platform? So very similar kind of to the last question. We can kind of work off some of the stuff that we used. Specifically, what we can do is, because it's independent of month, we can take that new date that we had from before. So I'm going to do df.head again real quick. We can use the new date, datetime object, to add a new column called date added month. And that can be equal to new date, df new date dot date.dt, because it's a datetime object, dot month. And with that, you can then do df.head again. We can see if we scroll over here, there is a date added month, and it's in terms of the actual, like, 1 is January, 2 is February, etc. Just keep that in mind when we're figuring out our answer. But again, same exact process repeats. The way that we got that is slightly different. We can copy this, change this to date added month, change this to date added month, because by nature of just taking the month, we're not looking at year at all. So we're going to get the aggregate count in the way that we would like. And we don't need to re-add df count here. And now let's sort the values. Oh no, I should have changed this to date added months summed. We see that June and December are the 2 most popular months to release content. And from a high level, as a data analyst, I would kind of think that June would make sense because it's the start of summer. People are home from school and probably have a little bit more time to consume content on Netflix. And then December, I feel like, is such a family time of the year where people also have the time to sit and consume new content. So I wonder if that has anything to do with the differences there, or maybe there's more like Christmas movies that are released or TV shows. But you see that every month has a good amount of content added to Netflix, but we do see, there is values that, this is a considerable difference. All right, for task number 4, we're going to switch things up a bit, and we will answer the question, what is the movie with the longest title in the data set? So to start out, let's just look at our data frame again. So we want to get the longest title. So here's the title, and we're specifically looking at movies. So we could steal that code we used up above just to filter by movies. So I'll go ahead and do that real quick. All right, now let's just do a new column called like title length. And that's just simply going to be equal to the length of, so I'm trying to think how to do this. Because if I just did length of movie df title, that's not going to be what we're looking for exactly, because that's going to just count the number of rows here, I believe. So what we could potentially do if we wanted to is use a list comprehension here. So we could do something like length of title for title in df or movie df. Okay, so that's going to take the length of each title for all titles in the movie df title. So that should work, because if we just put a length outside of that, we wouldn't actually be getting what we want. So I think this should do the trick. And now let's look at movie df. Title length, Dick Johnson is dead, 20. My Little Pony, A New Generation, sounds like a fire movie at 32. That looks right. So we could just simply take the max of title length. But I think what will be easier is actually to just sort values. So take movie df, top title lengths, we'll say, equals movie df title length, or movie df dot sort values on title length, sending equals true or false. And let's look at top title lengths dot head. So it's whatever is in here. We can't see all of this right now in the data frame. So if we want to just grab that value specifically, we could do something like index 0. So that should give us the, try doing .iloc 0 and then grabbing the title. Let's see what happens there. Look at that, we got it. Jim and Andy, The Great Beyond, featuring a very special contractually obligated mention of Tony Clifton. Sounds like a very interesting title. I'm kind of curious to look this up. Interesting. It's rated decently. Got good old Jim Carrey in it. Well, that is the longest title for a movie on Netflix. Cool, cool. That wasn't too bad of a task. All right, let's just keep moving down. We're going to do one final task, and then we'll switch to Dataiku. So task number 5. In this task, we are going to see which actor/actress shows up most frequently in the Netflix database. So this could be TV shows or movies. But this is definitely going to be probably the trickiest question that we have done. All right, and so how should we approach it? Well, I think always a good starting point is just kind of going back to our data frame. We see we have cast here. If we wanted to simplify this a little bit, we could just look at the data frame and maybe look at title and cast. And we'll get all these values. And we can't see everything here. One little trick you can use within Pandas is if you do pd.options dot display dot max column width. You can see how many characters it will display by default. If we wanted to, we could set this to something like 150 and then rerun this, and we get to see a lot more information about, the cast here. So it can be helpful if you have really kind of information intensive columns. And this definitely is helpful for us. We can see a little bit more names. But I think the key thing is we have these names and they're all separated by a comma. So I think I'm going to approach this in a very Pythonic way, in the way that makes the most sense just like immediately to me. But there probably could be ways to optimize this to be a little bit more pandas, capitalizing on the strengths of pandas. But feel free to pause the video and then resume when you want to see my solution. All right, the way that I'm going to approach this is instead of doing something like directly through pandas, I'm going to kind of use a for loop that just iterates over this entire data frame and kind of count things separately with a dictionary. And maybe to make things simple, I'll save this as its own data frame. Title and cast df equals that. All right, so I want to iterate through that. So I'm going to do for index comma row in title and cast df dot iterate rows. Just real quick, print index, print row, just so you can see what these are showing. So index is first. I just sometimes forget which order, if row goes first or if index goes first. So this is just a quick sanity check. But very useful to do in a for loop like this. And what I'm going to say is I'm going to call this actor names, or call it cast names to be a little bit more explicit. Cast names counter, how about? So what we're going to do with this is that we are going to look at the row. So movie cast equals row cast. We're going to print movie cast and break. And in some situations, we might not have any names here. So let's, how about do if index equals mod 5 equals index equals 5, we'll break just so we see a couple results here. Cool. Well, what we want to try to do, how about, is split this information on a comma. So let's see, we'll call this movie cast split equals movie cast dot split on the comma, and then let's print out movie cast split, and I'll just print out an extra row. All right, interesting. What we could even do here is those NaNs, that first value we saw, is causing issues when we try to iterate and split because it's expecting a string. So what I might do is say title and cast df equals title and cast dot drop na. And let's see what happens now if we run that. Cool. So the NaNs, the naughty numbers within our data set, if we run a command like this, we can eliminate them from what we're searching. So that's kind of a nice little trick you can use to not run into errors. But this looks good. I think the one thing that I do see here is some of these have extra spaces, and we don't really want that when we start counting. So there's a nice little tool that we can also use. I wonder if this is actually built into Split. let's see. Python split documentation. It doesn't look like it is. What I'm trying to do here is I want to strip. So there's a strip function which will get rid of the extra white space. So if I wanted to, I could do one more line, movie cast cleaned or something like that, or maybe even stripped, equals name dot strip for name in movie cast split. We'll now print that out. And we see now we get rid of those extra white spaces. So that's good. Then the only other thing I might recommend, it's usually good practice when we're working with strings to put it all in the same case, because you could see someone kind of screwing up entering one of these names and not capitalizing it in the same way every time. So I'm going to also lowercase all of this, see if that works. Cool. Doesn't look quite as nice, but when we're counting, for the sake of counting, it will be better for us. Finally, what we want to do is add each of those names to our dictionary. So I'm going to add another for loop here for name in movie cast stripped. We want to take our dictionary, which is the cast names counter. We want to get the name that we are looking for. And if we don't have that name, the fallback case will be set this to 0. And then we want to add 1 to that. So we can do cast names counter of the name equals whatever it was before plus 1. And if we hadn't seen it before, we'll make it 0, then plus 1. And that should be all we need to do. What we'll want to do at the end is just kind of print out the dictionary and sort it. And I kind of forget how to sort a dictionary off the top of my head. Okay, we're going to run this. So we see the entire dictionary here. And then what we can do is do sorted. And just for an FYI behind the scenes, I typed in the search sort dictionary by highest value Python, looked at the first top answer, and we see this. So I'm just going to copy that line and paste that in. Our dictionary is cast names counter. So we want also cast names counter. Let's see what we get there. And I don't love that just because it's not showing us the counts by the names too. So I'd rather have an answer that's preserving counts. So I think we can actually alter this slightly. Found another line here. Change the key. Keep the reverse equal true. Then surround this with dict. Look at that. All right. We see the top name in the Netflix shows from this database is Anupam Kher. I probably botched that name. I'm guessing, I also apologize if I'm completely off on this, but I'm guessing this might be like a Bollywood actor. So let's see the first actor that I know, Samuel L. Jackson. That definitely checks out. What other names are here? Seems like there's a lot of maybe Bollywood here at the top. See other names that I recognize. Adam Sandler, he's a fellow New Hampshire native, so I have a lot of respect for Mr. Sandler. David Attenborough, good old English actor, I believe, from the UK. Seth Rogen, James Franco, a lot of fun names here, but the answer here would be Anupam Kher is the name that shows up the most frequently in the Netflix database. Cool, that is the 5 tasks we're going to do with Python, but don't exit out of this video yet. We're going to walk through these same questions now with Dataiku. All right, to get started with the Dataiku platform, you can go to dataiku.com, then click on Get Started. So there's a few different options for installation. You can either do the online version, where you can get a 14-day free trial, or there's also the option to install the free edition. So you can kind of proceed with whatever way makes most sense to you and kind of look at some of the instructions here. For the sake of this tutorial, I'm going to use the online version. So I'm just going to do a 14-day free trial. All right, once you sign up or download the app, basically we'll have a platform that kind of looks as follows. You'll land in a little space that looks like this. I already have a test project up and running, but to create a new one and starting from scratch, you can go to New Project. There's some tutorial type projects, but let's just start this one from scratch. And we'll call this Netflix Analysis, how about? And to actually do anything, we need a data set, so we can go ahead and import our first data set, upload files, select files. We're working with this Netflix titles CSV. So you can actually upload a CSV right there, so that's definitely nice. If you want to like change up anything before you import it, you can click Configure Format over here. But we will not bother with that. I'm just going to go ahead and create. Cool. So we see we have the entire data set here. One thing that's nice is we can do all sorts of stuff just by like clicking into these columns. So like we can analyze like the different release years of all the items in this data set. So we see in 2018, there was 1,147 TV shows and movies that have the release year of 2018. And if we go back to our first question that was asked on the Python side of things, it was, what is the most popular release year for movies on Netflix? So we're almost there because we got just movies and TV shows with what we just showed by just clicking into a column. But what we want to do to just get movies, we can add a prepare step. So I went into the flow diagram here. Or actually, yeah. So I went to the flow before we were actually looking at the data set. We were exploring Netflix titles. So we want to go to flow, and then there's a bunch of recipes we can add. So we want to filter by movies. So I'm just going to call this Netflix titled filtered. That works, or Netflix titles movies. That might be a little bit more specific. We're going to keep this as a CSV format and create a recipe. Sampling method, we can either take the first number of rows. So imagine you have a really, really big data set. Because our data set is, in the grand scheme of things, not too big, we're going to just use the whole data. And then the filter we want to add is title should be equal to movie. And we can go ahead and run that. So a much more visual way to kind of access the data All right, so it looks like everything ran. If we go back to the flow, we now see that we have Netflix titles movies over here. We can go ahead and explore that. And oops, it looks like I made a mistake. I'm going to go back to our flow, look at the filter we added. I did title. I should have done type. So we're going to rerun this now. Array, flow, this, explore. All right, there we go. Now we have all the movies here. So to see the most popular release year, we can go ahead, go over to release year, click on the column and click analyze. And we see 2017 and 2018 are the top 2 release years with 767 movies released, movies that have that release year in our data set. And if we go back to the Python code, we can see that we got that exact same result. So that's always a good sanity check, getting the same results on 2 different platforms. So that was task number 1. Task number 2 now is finding the most popular date added for all of this content on Netflix. So because the date added question is not just movies, let's go back to our flow and let's actually work off of our original data set, the Netflix titles one. And we're going to add a prepare step. And we can, yeah, this is fine with me. Keep it as a CSV, create recipe. And so what we want to do here is we have this date added column, but if we analyze this, it wouldn't tell us the information we want because we want to just focus on the year. So we can click on this. We can actually just click on parse date. And one thing, it will try to automatically detect the format, but if it can't do that, it gives you some just suggestions of how it should be trying to process this. So I see that with the month name July, it lists that as MMM. So I'm going to start with MMM. And then the next thing is day. I guess just day is probably just fine. Yeah, okay, that matches everything that we want. And then it is comma, year with 4 digits. Looks like everything is passing. So it now knows how to interpret the parsing of the date. We can use the date format. Cool. And one thing that we can now do is we can click on this date added parsed, and we can click on extract date components. And note we can add new columns. So looking at question 2, which is finding the most popular date added year, we obviously want to add a year column. But then question 3 is what is the most popular month to release content? So we'll definitely keep this month column too. I'm going to get rid of the day column and then go ahead and run this. All right, so now we have the date added parsed year. We can analyze this. We see 2019 is the most popular year to add content on Netflix with 2016 contents added, followed by 2020 with 1879. And if we go to our Python code, good old sanity check, 2019, 2016, 2020, 1879. That looks good. So answer to number 2 is year 2019. And one thing that's super nice is immediately by just parsing this date, we can go ahead and analyze the date added. And we can see that the month of July is the most popular, followed by December with 827 TV shows or movies added then, and 813 added in December. Let's go ahead and look at our Python code. Does that add up? 827, 813. I think I might have said that this was June before, but it's definitely July, 7th month. That's my bad. Cool, so that's 1, 2, and 3 we've already knocked off on the analysis tasks. What was the task number 4? I'm going to go back to the flow. We look at our Python code. Task number 4 was what is the movie with the longest title in the data set? Let's go ahead and do that. So we can actually probably just add information on this to the prepare step that we were just working off of. So I'm going to click on this prepare step. I'm going to click edit. I'm going to add a new step. Actually, we want to do something with title, so I think we're going to have to click on the title column first. So I'm going to do click on title. I'm going to go to more actions, and I'm going to process with formula. And so I want to output some column called title length. And what's nice about this formula is there's all sorts of expressions that you can use to access details about values in your data set. If you Google search like Dataiku expression formulas, like you should be able to find resources on this. But length of a string column is just, you type in length and you can pass in that column. And if I exit out of that, we see we have title, and then title length is this next column. I'm going to go ahead and run this. Okay, it looks like it exceeded. Click on title length. We can sort. We don't, seems like there's some weird stuff that happened maybe with parsing the titles. I'm not sure. Or maybe these actually are the titles, yeah. H9, I've never heard of these. I definitely know 21, that's a good one. Sort it the other way, and we get the top title is, and we can expand this to see it fully. Jim and Andy, The Great Beyond, featuring a very special contractually obligated mention of Tony Clifton. So that looks good to us. Cool, and that's the same exact response we got in question number 4 on the Python side. So that looks good. I'm gonna go back to the flow. Oh, cancel. Let's run this, make sure it's all set. Going back to the flow. I'm gonna just go back and explore the data set that we had originally, because task number 5 is looking at the casts here, and it's trying to count up who the most popular actor or actress is within the cast. So in Python, we did like a for loop and iterated over and used a dictionary to count. We're going to do this differently with Dataiku. So I'm going to click back on Netflix titles. I'm going to, we could either put this as part of Netflix titles prepared, or we could do it separately. I'm going to just make this a separate, prepare, because the data set we're going to generate out of this one is going to be definitely different. So I'm going to just call this Netflix titles casts, or like cast counting, maybe something like that. Keep it as a CSV, create recipe. And what we're going to do here is to count these, we're going to go ahead and extract out, like kind of, we're going to add a row for every one of these names that are in one of these movies or TV shows. So we're going to go ahead and add a new step. The step that we want to do, and I wonder if we click on this if we would see it. We don't see it there, but one thing that's pretty useful, and you use this technique in various data analysis tasks, but I'm going to split and fold the data. And if I look, I'm going to delete this real quick and just look at the description of that. Split and fold. This processor splits the value of a column based on a separator and transforms them into several rows. So we'll split on the comma and then have each name listed individually. So the column we want is cast. The separator we want is the comma. And we see already nicely like all of this information. Whether we want to keep empty chunks or not. I would be fine keeping empty chunks. I don't think that would really matter. So I'm going to just click on this. I don't think it'll change our answer at all. I'm also going to add a new step here, which is just converting this to lowercase, just in case we ran into any of those same errors we mentioned before. So we have those two steps now listed. Now we want to go ahead and like count those. So same as with Python, I'm going to add a new column. Fill column we'll use. Call this count. And we'll just fill it, no, not country. We'll just fill it with the value 1. And we'll run all of this. We've now prepared our data. The last step will be to group by the cast name and then sum that count column. All right, so I'm going to go back to the flow, cast counting. We're going to add a new step, which is a group step. We're going to group by the cast. That's fine with me. Keep this as CSV. Create recipe. And then with this group by, we have a nice visual way of like seeing what we want to do. We want to take the count and sum that. So I'm going to click on sum here. And I'm going to go ahead and run this. So now let's look at what was outputted from that. Explore the data. 2 Chainz. I wonder what movie 2 Chainz was in. 50 Cent. 50 Cent was in 5 movies. Wow. We'll sort by this. We'll flip it the other way. Cool. So we see the Anupam Kher there at the top with 43. He appeared in 43. One thing that I noticed we're missing is like before we had like Samuel L. Jackson right up in here somewhere. So I'm not quite sure what happened to him. This is probably worth sanity checking. So if we look over here, we can explore what it was before we counted. And I'm going to just type in Samuel L. Jackson. For whatever reason, we only see him in 4 rows. And this is something to like be considerate of, I guess, with Dataiku, is that because it's like kind of geared towards working with very, very large data sets, sometimes it will clip and shrink data sets. So you're just working with a sample so that things move more quickly. So we see that it's just saying first like 10,000 rows here. What we want to actually do here is let's just make this bigger. So I'm going to just say that we can take the first 100,000 rows. I'm going to now search by Samuel L. Jackson. And because we see it's 64,000 rows being considered, and it didn't go up to that 100,000 limit, I think we're probably good here. And we see we have a bunch of rows now that have Samuel L. Jackson. And that looks much better. So I'm going to rerun this step non-recursively. I just want to run that one more time so that we get this count probably with the full set of data instead of just that component. Explore. Did it not finish running? Did I jump the gun here? Why is the job failing? Oh, it's already built. Go explore this. Come on, Samuel L. Jackson, be there. Where are you? What the heck? Oh, this is also just... Did it not save on me? 100,000 Save and refresh sample. I think we maybe have to do it up here. All the Samuel L. Jacksons are there. That looks good. That looks good. Rerun this. Finally, look at the data again. All right, there we go. Looks like we got some additional names in here now. And we do see Samuel L. Jackson there with 24. We see Adam Sandler. Okay, so we got that answer pretty quickly because we did see this name right at the top, but we did miss some rows because our sample size wasn't the full data set. So just one thing to be a little bit careful with Dataiku. But that looks good, and that was pretty straightforward working with this data. I think each person's going to have their own trade-offs, and each person's going to have tools that make sense for them. Like we got a lot of those answers very quickly with Dataiku. That was at the expense of maybe a little bit more overhead to import all this data and get this all going. You also have to kind of be a little bit familiar with the Dataiku platform, but we can grab insights super quickly. I think the one expense, it might come at is that you might have a little bit more flexibility when you just do straight raw Python. But even saying that, there's ways within these flows you can add, Python to your code recipe. So there's a ton of stuff you can do with Dataiku. Useful tool to have in your, tool set, especially if you're working with people that don't have Python experience. So hopefully this was helpful. Hopefully it was cool seeing these two different methods of, two different approaches. All right, I think that's all we're going to cover in this video. Hopefully you found this video useful. Hopefully it was interesting to see the same set of problems answered with two different methods. If you did enjoy this video, it'd mean a lot if you throw it a big thumbs up, and also subscribe to this channel if you haven't already. There's a lot more good data science, data analysis content coming, so be sure to subscribe to not miss anything. All right, this video was a lot of fun. If you have any questions, let me know in the comments. But until next time, everyone, peace out.